If you want the code quickly, just leave your email below, and I'll send it to you.
However, typing along as we proceed enhances understanding and is highly recommended. Welcome to our artistic Python journey. Today, we're using the Turtle Graphics library to create a mesmerizing, colorful pattern.
Turtle Graphics is a popular way to introduce programming, bringing fun and art together.
By the end of this tutorial, you'll have a stunning piece of art and a deeper appreciation for Python's capabilities.
We're also importing the ColorSees module, which allows us to convert color space values. Today, we'll use it to generate a beautiful range of colors by changing hue, saturation, and value.
It's amazing how math and color theory can combine to produce stunning visuals, isn't it?
First, we set up our drawing canvas to be 800 by 800 pixels.
This gives us a nice, large area to work with, ensuring our artwork will be both detailed and visible.
We set the drawing speed to the fastest.
We're not here to watch paint dry. This speed allows our program to render the artwork quickly, keeping the process exciting.
The tracer method controls how often Turtle updates the screen.
By setting it to 10, we strike a balance between rendering speed and performance, making our drawing process smoother.
We define the width of our pen to be 2 pixels. This thickness makes our design's lines distinct and visually impactful, standing out against the black background.
Choosing a black background enhances the vibrancy of our colors, making them pop and giving our design a cosmic, deep space feel.
Here begins our outer loop.
It will repeat 25 times, allowing us to layer colors and shapes to create depth and complexity in our design.
It's like building a visual symphony. Our inner loop repeats 15 times. In combination with the outer loop, it helps us create a repeating pattern of colors and shapes, weaving a tapestry of visual intrigue.
We calculate our color using the HSV color space, then convert it to RGB.
This line is where art meets science, blending color theory with coding logic. We turn our turtle right by 90 degrees, setting the stage for the next segment of our pattern. Here we draw a segment of a circle.
The radius changes with each iteration of the outer loop, creating a pulsating effect.
Turning the turtle left realigns our drawing direction, preparing for the next curve. Another circle segment is drawn, mirroring the first.
This symmetry adds a pleasing balance to our design.
A sharp turn to reverse direction, adding an unexpected twist to our pattern's flow. We draw a smaller arc, introducing a new shape and rhythm to our design. It's these surprises that keep the viewer engaged and delighted. Once our drawing is complete, we hide the turtle cursor.
It's like signing our artwork, leaving nothing but the beauty we've created.
And we're done. Our Python masterpiece is complete. Thank you for joining me on this creative coding adventure.
Remember, the possibilities with Python are as limitless as your imagination. Feel free to modify this code, experiment with colors and shapes, and make it your own.
If you enjoyed this tutorial and want the source code, leave your email in the comments. Let's keep creating together. Alright, We've just seen the program in action and checked out the results. If you found this useful and enjoyed the content, don't forget to hit like, subscribe, and share with others who might benefit.
For more in-depth support or engineering consultancy services, head over to eprogrammer.com.
Looking forward to seeing you in the next video.